Here we have problem relating distance and time. A light plane flying east at 300 kilometers per hour passes over airport 10 minutes before a second airplane flying south at 420 kilometers per hour passes over the same point. Assuming that both the airplanes are at the same altitude, at what time is the distance between them a minimum? So here, let's sketch the scenario, right? So it's kind of like this. One plane is traveling south, the other one is traveling east. Now, the one which is traveling east is going at the speed of 300 kilometers per hour. So it's 300 kilometers per hour, the speed in this direction, east. The one which is traveling south is traveling with the speed of 420 kilometers per hour. Now we need to find minimum distance between these two planes at any instance of time. Now to start with, what we should do is, since plane A, which is going east, passes this point 10 minutes before the other plane comes, let's revert back to the initial position. That means just when this plane was at this position. How far was the other plane? So the distance was the distance which this plane covered in 10 minutes, right? 10 minutes is 10 divided by 60 hours, correct? So let's find that distance. So that distance should be, as we know, distance, speed and time triangle, correct? You remember that? So distance is speed into time. Now since speed is 420, right? So distance should be 420 times time. And time is actually 10 minutes. So convert 10 minutes to hours. So you got so many kilometers. When you convert and multiply, and that gives you distance of, when you cancel this off, 10 goes 670, right? So this plane is actually 70 kilometers away at the instance when the first plane is just over the airport, correct? So what we can say from this diagram is that this distance, if this is 0 for us, this is 70, correct? Now, at this instance, plane A is over the airport and plane B, which is coming south, is 70 kilometers away, just north. Now let's say the time starts now. So let's define a variable t when plane A is just over the top of airport. That is time t for us, right? So let's write down. So let t be the time when, let's call it plane A, moving east, is just over the airport, right? So we're starting from that time t, right? So at that time, plane B is 70 kilometers away, north of this position, right? Now as the time goes, we find this plane is approaching and the other plane is going away from the point, correct? So at any instance of time, we can say, let's say it has approached this much and the other plane has moved a bit distance away. That will give us the distance between the two planes, correct? So let us say after time t, this is my scenario. So in time t, how much distance will south coming plane fly? It will cover a distance of 420 times t, right? And how about the plane flying east? It will cover a distance of 300 t from here to here. Now, if it covers 420 t, earlier it was 70 kilometers away, what is this distance from here to here? That distance will be 70 minus 420. So we'll write it in a different way so it doesn't get confused with that. So we can write this as 70 minus 420 t, okay? So that is this distance. Now this forms, here we have a right triangle, right? So in right triangle we know the two sides. So the distance between them will be, let us say s is the distance between them. It is square root of this square plus that square, correct? So I hope you get the formula. So we can say distance between the two planes at at any instance of time t, so that means as a function of t, is equal to 300t, which is this 300t square, plus 70 minus 420t square root. So we use Pythagorean theorem and got this equation, right? So s square is equals to sum of squares of these two sides, since this is right angles, correct? Now this is our function in time. To find the minimum distance, we should find the derivative of this. Therefore, derivative of this is equals to, when you do square root derivative, you get half of this, and that comes in the denominator. So let's write down that first. 2 times square root of all this, which is 300t whole square plus 70 minus 420t whole square, correct? And the numerator will be derivative of these terms, which are the inside terms. So the derivative of the first term will be 2 times 300t times inside function, that means 300. And derivative of this term will be plus 2 times 70 minus 420t times inside function, which is minus 420, correct? So that becomes the derivative of our function. Now, since we are interested in finding the critical points, s dash t should be 0, right? So that is point where we expect a minimum or a maximum. Now to decide whether it is minimum or maximum, we will see the rate of change of this distance, how it changes. Does it change from increasing to decreasing or from decreasing to increasing, right? That will decide whether it is minimum or maximum, right, at this critical point. Now when we solve for this, then now you can factor out 2, right, and then cancel it. So that is one simplification. But in any case, when we solve for this, then the denominator, when you multiply, it becomes 0. So we are more bothered about this factor to be equal to 0. So let's solve for this now. So this factor is, at present what I'm doing is, I'm factoring out 2 from here. I factor out 2 and cancel it. Very simple calculations. And then I want to equate all this to 0. So I get here 0 equals 2. So we can write 300 times 300 is 90040 t. And then we have, let me use calculator. So we have 70 times 420 with a negative sign. So let me write the sign first. And then we have 70 times 420, that is equals to 29,400. 29,400. And then we have 420 times 420, so we have 420 times 420, that is equals to 176,400. And that becomes positive, right? So positive 176,400. So these are the terms which we get here, right? Now, well, this is with t, correct. So we can solve for t now. So t terms is 176,400 plus 990,000. Okay, let's add 90,000 to it. So plus 9 4 zeros, 1 2 3 4. We get 266,400. So we get here 266,400 t minus 29,400, correct? So from here we can find what t is. So t is equals to, we'll take this term and divide by that number. So 29,400 divided by 266,400, that is equals to, so 29,400 divided by 266,400 equals to 49 over 444. I'll change it to decimals. It is 0.11. So 0.11 is the critical time for us when this could be a minimum or a maximum. Now the second question is to decide whether this is minimum or maximum, right? Now let me clearly write down my s dash t, which I was trying to solve here, before equating it to 0, which is kind of here. So let me write it down in different ink. So what I'm trying to do is, this is my simplified s dash t. So I'm writing here s dash t, that is change of distance between the two planes at any instance of time, is given to me as 266,400t minus 29,400, right? So this is the equation which I'm trying to isolate, because from here I will figure out whether the distance is increasing or decreasing, right? So let me write it separately. We have this function s dash t equals to 26,400t minus 29,400, correct? S dash, change in distance, right? Change in distance. So now we find a critical number. That's the critical number, is 0.11. Now what we need to test is that on either side of this critical number, how is rate of change of distance changing? This is what we have to check. So what we will do here now is, so that is the point where t is 0.11 for us. So let's take a test point on either side, and let's say we have a point 0.12 on this side and 0.10 on the other side. So what we will do now is we'll plug in the value in this equation. So we say s dash of 0.10 is equals to what? It is equals to 266,400 times 0.10 minus 29,400, correct? And let's find what this is. So this will be 266,400 times 0.1 minus 29,400, and that gives us minus value, right? So this value is negative 2760. Anyway, the important thing here is that when we checked rate of change, it is negative here in this region. That means before time 0.11, distance was decreasing, right? So it is negative, means the distance is decreasing till 0.11. And now let's plug in the other value, which is s dash 0.12. And what do we get? So we get, now straight away I'll put 266,400 times 0.12 minus 29,400. We get 2568 with plus. So at this time we get plus 2568. So this value is positive. Do you see that? So afterwards the value is positive. That means the distance has started increasing between the two planes. Do you get the point? Since this is positive, that means the distance is increasing now. Rate of change of distance between the two planes is increasing. And therefore, at the value which was s dash of 0.11, we have a minimum. Do you understand? Now, this is very important to show in examination, how you show that this critical point is a minimum. It is a minimum since before this, the distance was, rate of change of distance between the two was decreasing, and after this it started increasing. Therefore, this is minimum, right? So that is what I'm trying to emphasize here, and I hope you get the point. Thank you and all the best.